This is the Physical Science paper for 2015, part 4, and we're looking at question 18. This will be criterion 8, so the second of the chemistry criterion. So let's turn it over to the start of question 18. So, got everything we need: pen, calculator, information sheet, everything's good. So, balance the following chemical equation. So we've got H2SO3 aqueous plus silver or AgNO3 aqueous to give Ag2SO3 solid plus HNO3 aqueous. So it looks like that we're taking two aqueous solutions here. It looks like an acid and a silver. It looks like a metal and a non-metal, so it's going to be ionic. And we're going to create a precipitate, because it's a solid, plus HNO3 at the end. Alright, so balance this equation. What are we going to do here? So let's have a look. On this side we've got two hydrogens and we've only got one hydrogen over there. Right. Over here we've got SO3, we've got one SO3, one sulfate. And over here we've got one as well. Over here we've got one silver, and over here we've got two silvers. And over here we have got NO3. Okay, and over here we've got one NO3. So what we're going to need is we're going to need to double up the number of, so let's see what that does. Two silvers there matches the two silvers we have there. And if that is going to be the case, then we're going to have one hydrogen here, but we need two hydrogens over here. And that's given us this now, it's given us two nitrates there, and that's given us two there. So if we do that, and that's it. Write a balanced chemical equation for each of the following reactions. So, when solid lithium is added to water, an aqueous solution of lithium hydroxide is formed and a gas is given off. So, we're looking here to see what type. We've got lithium is added to water. Now, lithium is an unstable metal. We looked at those when we did those throughout the year. So what happens there is that we're going to take lithium, and that's going to be a solid. And we're going to add that to H2O, which is going to be a liquid. Now what's going to happen here is that one of these hydrogens is going to be given off, and that's going to leave this as an OH minus, and lithium, if we look at our particular common positive ions and cations, we can see lithium here is 1 plus, hydroxide here is 1 minus. So if it's going to get rid of a hydrogen, so it's going to have LiOH, and that's going to be aqueous. We can just check that if we need to. We've got hydroxides, they're all insoluble except lithium hydroxide, so that's going to be aqueous. Plus, and what's going to be left over? Well, we've got the H, and what does H form? It forms H2, and that's going to be a gas. Now, if we've got everything here, lithium has got 1, 1. We've got 1, 2, we've got 1, 2, 3 hydrogens over here. We've got 1 oxygen, 1 oxygen, so we need to muck around with that a little bit. So let us say that if we make that 2 hydrogens, we'll leave that till last. So we've got 3, so we need to make that 2 to make 4 there, and we make that 2, that gives us 2 oxygens. Then we need 2 oxygens there. We've got 2 hydrogens and 2 hydrogens, which is going to be a total of 4 hydrogens, which we've got. And we've got 2 lithiums, so we need 2 over there. And that brings us to that one. When iron 3 sulfate precipitate sulfate solution is added to a test tube containing sodium hydroxide solution, a precipitate of iron hydroxide forms. Okay, so what's going to happen there? So, iron 3 sulfite. Well, let's have a look. Iron 3 is obviously iron Fe3+. And we're looking down at sulfate. Sulfate is going to be SO4 2 minus. So we've got a 3 plus with a 2 minus here. So in that case, what we're going to need is we're going to have 2 of these to make that up to 6 plus, and we're going to need 3 of these to make that up to 6 minus. So iron sulfate, is going to be Fe2 SO4 3. Now, sulfates, where are your sulfates? I assume that these are all going to be soluble. They're all soluble except, no, iron's not there. So that's going to be aqueous. Plus, leave ourselves a gap. Sodium hydroxide, NaOH. And that's going to be aqueous as well. Sodium, where are we? Sodium hydroxide. And what's that going to give us? Well, we'll go down to the next line for that. So what's this going to precipitate of iron 3 hydroxide? Well, Fe, looking over here, we have Fe3 plus and OH minus. So what we need there is we're going to have Fe OH3, and that's going to be a solid because it's told you it's a precipitate, plus what's going to be left over. So we're going to have sulfate and sodium. So sodium sulfate, what does that look like? Looking over here, our sodium is going to be 1 plus, and sulfate is 2 minus. So we're going to have Na plus SO4 2 minus. So we need 2 of those to match up to one of those. So we'll need Na2 SO4. Didn't really need that. And I would assume that the sulfate, they're all soluble except for no sodium. So that's going to be aqueous as well. Now we need to make this balance. We've got, looking over here, we've got 2 ions there and 1 iron there. We've got 1 hydroxide there and 3 hydroxides there. Right. We've got 2 sodiums there and we've got 1 sodium there. And we've got 3 sulfates there and we've got 1 sulfate there. So what can we do? There's nothing by itself which we could use last, so it's a little bit of guess and check. So 2, if we make that into a 2 there, so that iron there and the iron there equal out. Now that leaves us with 6 hydroxides, and we've got 1 there, so I might make that 6, see what happens. Now, what that leaves us with is we've got 3 sulfates there. I do need to put 3 in there, so that we've got 3 sulfates, and that gives us 6 sodiums, and there's 6 sodiums there. So that looks pretty good. Next one, write a balanced equation and name the products of the reaction occurring between solutions of ammonium phosphate and calcium chloride. Okay, let's go back to the table. Ammonium is NH4 plus, and what have we got here? Phosphate. Phosphate's over here. PO4 3 minus. And the other one is calcium chloride. Well, calcium is 2 plus and chloride is 1 minus. So it's going to be calcium 2 plus Cl 1 minus. So we're going to add these up. So this one has got 1 plus, that's 3 minus, so we need NH4, and we need 3 of those for a PO4, and I assume that is going to be phosphates. They're all insoluble except for ammonium. There it is. So, well, you'd expect it to be aqueous, you'd expect it to be soluble, otherwise they wouldn't get a reaction. Plus calcium. So we've got calcium 2 plus and we've got chlorine 1 minus, so that's going to be CaCl2. Let's go back over and have a look at our solubility table. Chlorides, they're all soluble except for silver, lead and mercury, and calcium is none of those. So we shall go back here and have a look at that. Aqueous. What is that going to produce? Name the products. Write a balance and name the products for a reaction occurring between solutions of ammonium phosphate and calcium chloride. Well, these are basically acting as ionic substances. I know there's not a metal in there, but that ammonium acts as a cation in that sort of behaviour. So what's going to happen is, let's say that the ammonium and the chloride come together. So we'll get NH4Cl. And is that going to be dissolved? Let me see. Chloride. Yes, we just checked that. They're all soluble with that one. So that's going to be aqueous plus, what have we got here? Calcium 2 PO and phosphate is 3 minus. So calcium, we'll need 3 of those, and we'll need PO4. Oops, I'll put that up there. Sorry, put that down 3, and that one's 2 in there. And phosphates, what are they doing? Phosphates, they're all insoluble except for lithium, sodium, potassium, rubidium, or ammonium. Now this one is calcium, so that one is insoluble, which means that it is a solid, which means that it is going to form a precipitate. Okay, so what we have here, we need to balance this equation now. We have got here 3 ammoniums, and we've only got 1 ammonium there. Over here we've got 2 chlorides, but we've only got 1 there. Now what are we going to do about that? If I make that, and this one's calcium, and we've got 3 there, and we've got 2 phosphates there. So if that's that, if I make that 3 to match up with that calcium there, then that gives us 6 chlorides. And if that's 6 chlorides, and we make that 6, now we've got 6 ammonium, and we've got 2 phosphates here. So if I put 2 in front of that, then that balances that out. So we've got 2, 3, 6, and 1 in front of that. And what are the products called? Well, the ammonium chloride and that's going to be solution plus calcium phosphate solid. Whew, there's a bit there, but that's question 18.